What's good? What's good? What's good with your boys? Y'all already know. Like, subscribe, hit that bell, turn on notifications so you don't miss another lit video. So today we finna be watching 15 machines that do incredible things. So without further ado, make sure you like, subscribe, hit the bell, share this video, comment what else you want to see. And yeah, let's keep it turned. You already know. We gotta always keep it turned. Let's get it.
Hey everyone, we're taking a look at 15 different machines that do incredible things. Starting with number 15, the Vortex Bladeless Turbine. The Vortex Bladeless Turbine is an unconventional wind energy device designed to capture wind power without conventional rotating blades. It was invented by David Yanez and features a vertical mast made of lightweight materials like fiberglass and carbon fiber. Now, unlike traditional turbines, it operates on vortex shedding. This is a phenomenon where wind-induced vibrations are converted into electricity through magnets and coils. The turbine's design is inspired by these vortices, swirling air patterns formed when wind encounters obstacles. These eliminate the need for gears and bearings, reducing maintenance and complexity. Now, in terms of size, the Vortex Bladeless Turbine comes in various models, with heights ranging from around 30 to upwards of 120 feet. Its smaller footprint makes it suitable for urban environments with limited space. While this turbine may not match the power output of traditional turbines, it does present a practical and cost-effective solution, particularly in urban environments. One notable aspect is its silence during operation, addressing noise concerns associated with traditional turbines. This turbine draws inspiration from von Karman's Vortex Street, a fluid dynamics phenomenon where alternating vortices from behind a bluff body, adapting this concept for efficient wind energy conversion. Let's go to number 14, Biorobotics Robotic Stingray. So, the Robotic Stingray, this is a nifty little underwater robot designed to mimic the locomotion of a real stingray. Developed by researchers at Harvard University's Weiss Institute for Biological Inspired Engineering, this biohybrid robot is part of a broader effort to create machines that can navigate and interact with the environment in ways inspired by natural organisms. The Stingray's most unique feature, hands down, or fins down, lies in the biomimicry of the Stingray's propulsion mechanism. This device is constructed with a flexible silicone body, and it's powered by a combination of muscle-like structures made from thin layers of gold and a layer of rat heart muscle. These muscle cells contract in response to light, allowing the robot to move in a manner similar to a real stingray. The researchers aim to create a biohybrid system that could serve as a platform for studying the integration of biological tissues with synthetic materials in a controllable way. The project was led by Kevin Kit Parker, a professional of bioengineering and applied physics at Harvard, and he was motivated by the desire to advance soft robotics and biohybrid systems. The fusion of synthetic materials with living cells enables the robot to respond to external stimuli and navigate its environment in a manner more adaptable than traditional rigid robots. It also just looks super cool as it glides through the water. Number 13, the Large Millimeter Telescope. The Large Millimeter Telescope, or LMT for short, is a colossal radio telescope conceived in the late 1990s through a collaboration between the University of Massachusetts and the National Institute of Astrophysics, Optics, and Electronics in Mexico. Its conception aimed to create a powerful tool for observing millimeter and submillimeter wavelengths. It was completed in 2011. The LMT stands atop the Sierra Negra volcano in Mexico at an elevation of about 15,000 feet. It's got a massive 164-foot diameter dish, making it one of the largest single-aperture telescopes of its kind. The LMT's colossal size allows it to capture faint signals from astronomical objects, aiding in the study of star formation, galaxy evolution, and the characteristics of interstellar dust. Operating in the millimeter wavelength range, the LMT utilizes its enormous dish to collect electromagnetic radiation. Now, it employs a precise surface that can be adjusted to minimize any distortions caused by atmospheric conditions. Situated near the Large Monocular Telescope and Gran Telescopio Canarias, the LMT forms a part of the International Astronomical Observatory at the Sierra Negra site. And notably, it played a critical role in the groundbreaking observation of the first ever image of a black hole captured by the Event Horizon Telescope collaboration in 2019. This achievement marked a significant milestone in astrophysics, providing a visual representation of the event horizon surrounding a supermassive black hole in the galaxy M87. Number 12, Deep Blue. So Deep Blue, a chess-playing computer, emerged as a pivotal milestone in artificial intelligence during the 1990s. It was developed by IBM. The project aimed to create a machine capable of defeating the reigning world chess champion. The concept of Deep Blue originated in the mid-1980s, evolving from earlier chess-playing programs developed by IBM. The initial prototype, known as Chip Test, paved the way for subsequent improvements and the eventual creation of Deep Thought, the precursor to Deep Blue. Deep Thought gained attention for its competitive performance, but it was Deep Blue that would make history. It featured a highly parallel architecture comprised of custom hardware for chess-specific calculations. Its processing power was formidable for its time, with 30 specialized chess processors working in tandem. The machine was specifically engineered to analyze and evaluate chess positions at an extraordinary speed. Now, the software behind Deep Blue incorporated some sophisticated algorithms for chess move evaluation and selection, and its software evolved through a combination of human expertise and machine learning techniques, enabling it to adapt and improve itself over time. Deep Blue gained widespread recognition when it faced world champion Garry Kasparov in a historic match in 1996. Although Kasparov emerged victorious, a rematch in 1997 proved pivotal. Deep Blue, with improvements in both hardware and software, secured a historic win, making it the first time a reigning world champion lost a match to a computer under standard chess tournament conditions. Number 11, CIMAscope. So it's quite simple. The CIMAscope is an instrument designed for visualizing sound vibrations, developed by John Stuart Reid in the early 21st century. This device provides a unique way to observe and understand the intricate dynamics of sound in a tangible and accessible manner. John Stuart Reid, a British acoustics engineer, aimed to bridge the gap between the auditory and visual aspects of sound, enabling a deeper exploration of sound phenomena. The CIMAscope comprises a membrane or surface that responds to sound vibrations, typically water or a thin layer of particles. A special camera system captures the vibrations induced on the surface by sound, and the resulting patterns are then translated into visually stunning images. The design allows for the visualization of complex wave patterns produced by different frequencies and harmonics. But how does it really work? Well, when sound interacts with the chosen medium on the surface, it induces vibrations that create these unique patterns. The camera captures high-resolution images of these patterns, providing a visual representation of the sound's frequency, amplitude, and harmonic structure. The CIMAscope essentially translates the sound into visible form, offering insights into the intricate world of sound waves. This CIMAscope finds applications in various fields too, including music, medicine, and scientific research. In music, it allows musicians and composers to explore the visual patterns associated with different musical notes and harmonies. In medicine, the CIMAscope has been used to study the effects of sound on biological tissue, offering potential insights into therapeutic applications. Most notably, it's been used to visualize the sound frequency.
There is dimensional entities that are walking among
Used to visualize the sound frequencies associated with various musical instruments, human vocalizations, and even the sounds of animals. It's contributed to our understanding of acoustics and has the potential to influence fields ranging from music composition to medical diagnostics. It's pretty cool. Number 10, the 3Doodler. When 3D printers first hit the mass market, things seemed a little too good to be true. But alas, regular folk finally had this amazing technology at their fingertips. But these big, intricate machines were kind of intimidating. Thankfully, Peter Dilworth, Maxwell Bogue, and Daniel Cohen of the Wobble Works made it smaller, cooler, and more accessible than ever. And thank God. The 3Doodler is a 3D printing pen that allows users to create three-dimensional objects in real time. It operates by extruding heated plastic, which quickly cools into a solid structure, enabling the freehand creation of 3D objects. The pen utilizes plastic thread made of materials like styrene, polyacetic acid, or thermal polyurethane, melted and cooled through a patented process. This is an amazing machine, yes, but the story behind it is even more amazing. With 3 models, Start, Create, and Pro, catering to children, general consumers, and professionals respectively, the 3Doodler has gained popularity for its versatile applications. Its origins trace back to a prototype built in 2012 by Maxwell Bogue and Peter Dilworth at the Artisans Asylum in Somerville, Massachusetts. The idea emerged after a 3D print job delay led them to transform the printer into a pen-like device. Wobbleworks launched a successful Kickstarter campaign for the 3D Doodler in 2013, 2015, surpassing the 30 grand fundraising target within hours, and the campaign's popularity resulted in over $2 million in pledges, highlighting the strong demand for the innovative 3D printing pen. Number 9, the Semi-Automated Mason. The Semi-Automated Mason, or SAM as its friends call it, is a robotic bricklaying system designed for the construction industry. Developed by Construction Robotics, SAM represents an innovative approach to bricklaying, aiming to increase efficiency and productivity. It's a robotic arm mounted on a track base that works alongside human masons to lay bricks. It automates the repetitive task of placing bricks while allowing human workers to focus on more complex aspects of the construction process. SAM can lay bricks in various patterns too, and its versatility makes it suitable for different types of construction projects. SAM operates by first analyzing the architectural design using a 3D CAD model, and once this layout is determined, it picks up bricks from a conveyor belt and precisely places them in the predetermined pattern using a robotic arm. The system incorporates a laser-guided targeting system to ensure accuracy too, and it works collaboratively with the human workers who handle tasks such as applying mortar and making adjustments as needed. The development of SAM traces back to the increasing demand for efficiency on the construction site. Construction robotics aim to address labor shortages and enhance construction speed by introducing automation in the bricklaying process. Now, it is known for its remarkable speed compared to human bricklayers. While the exact speed can vary based on factors such as the complexity of the project and the skill of the human workers, it generally outpaces traditional bricklaying methods. Of course, SAM's introduction into the construction industry has sparked discussions about the future of automation in construction. While it streamlines the bricklaying process, SAM does not replace human workers, but complements them. Its precision and speed contribute to a more efficient construction practice, and this addresses challenges faced by this industry. Number 8, the Da Vinci robot. So it takes a steady hand to be a top-notch surgeon. So that's where the Da Vinci robot comes in. This robot consists of a console where the surgeon sits, robotic arms equipped with surgical instruments, and a 3D vision system. The surgeon controls the robotic arms from the console, manipulating the instruments with hand and foot controls. The system translates the surgeon's movements into precise, scaled-down actions by the robotic arms. Surgeons operate the robot by inserting small instruments through tiny incisions in the patient's body. Now, these robotic arms mimic the surgeon's hand movements, but with a higher degree of precision and a wider range of motion. The 3D vision system provides detailed, magnified views of the surgical site, allowing for accurate and delicate maneuvers. This system was introduced in 1999, and it's since evolved to become a widely adopted technology in various surgical fields. Its development aimed to address limitations in traditional laparoscopic surgery and open surgery, offering a minimally invasive alternative with improved capability. This robot offers several advantages, including smaller incisions, reduced blood loss, and faster recovery times, and improved cosmetic outcomes compared to traditional open surgery. Its precision and dexterity make it really beneficial for complex surgeries in urology, gynecology, colorectal, and other specialties. The name Da Vinci pays homage to the renowned Renaissance man Leonardo da Vinci, reflecting the system's integration of advanced technology and the fusion of art and science. While Da Vinci's drawings explored anatomical concepts, the Da Vinci surgical system brings those concepts to life in modern surgery. Moving on to number 7, tunnel boring machines, Bertha. So Bertha is a 57.5-foot diameter tunnel boring machine. It was crafted for the Washington State Department of Transportation's Alaskan Way Viaduct Replacement Tunnel project in Seattle. Built by Hitachi Zosen Sakai Works in Osaka, Japan, its assembly finished in Seattle in June of 2013. Tunneling commenced on July 30th, 2013, with an initial completion target set for December of 2015. Now, encountering an unexpected impediment in December of 2013, Bertha's progress was halted due to damage in the main bearing seal system. Over 2 years were spent on repairs, including lifting the cutter head for replacement in 2015. And then Bertha resumed tunneling in December of 2015, but faced some additional challenges too, including a barge incident and a sinkhole. Governor Jay Inslee temporarily halted the work in January of 2016, citing safety concerns, but operations then resumed in April of 2016. Despite delays, the tunnel boring concluded on April 4th, 2017, and it opened up on February 4th, 2019. The tunnel boring faced complications, including hitting a steel pipe, damaging blades, and overheating due to a damaged main bearing seal. Now, delays, lawsuits over insurance claims, and groundwater issues further extended the timeline. And where is Bertha now? Well, disassembly began within the tunnel in 2017. Her parts were removed and deemed not to be reusable. By 2019, she was scrapped. Auf Wiedersehen, Bertha. Number 6. The Exovest. The Exovest, developed by Exobionics, is an exoskeleton designed to provide assistance to workers engaged in tasks involving overhead arm movements. This wearable technology aims to reduce the physical strain on shoulders and arms of industrial workers, offering support and enhancing overall efficiency. This vest operates as a wearable exoskeleton that aligns with the upper body. It's significantly engineered to aid individuals in industries such as manufacturing and construction who perform repetitive or prolonged overhead tasks. The exoskeleton is equipped with adjustable mechanical arms that provide lift assistance, reducing the effort required for activities like reaching, lifting, and performing overhead work. The design of the Exovest focuses on ergonomics and ease of use. It features lightweight and adjustable structure that comfortably fits over a worker's upper body, and the mechanical arms are strategically placed to mirror that of the natural arm movements. One of the key advantages of the Exovest is its potential to minimize the risk of musculoskeletal injuries. By providing a mechanical support to the arms, the exoskeleton aims to alleviate physical strain on the wearer. It operates in tandem with the user's natural movements. Sensors detect when the wearer is lifting or reaching, triggering the mechanical arms to provide lift assistance. This is a seamless integration, and it allows workers to maintain their mobility while benefiting from the supportive features. Workers who don the Exovest experienced enhanced comfort and reduced physical strain during repetitive tasks. This includes manufacturing settings where assembly tasks require extended arm movements and construction sites where workers handle materials above shoulder height. Think automotive assembly lines, shipbuilding, and construction, just to name a few. Number 5. The D-Wave Quantum Computer. The D-Wave quantum computer stands at the forefront of quantum computing technology, representing a significant leap in computational capability. Developed by the Canadian company D-Wave Systems, this computer harnesses the principles of quantum mechanics to perform complex calculations that traditional computers struggle with. The primary function of this computer is to solve optimization problems and tackle complex computations by leveraging the principles of quantum superposition and entanglement. It utilizes these things called quantum bits or qubits as opposed to classical bits, allowing it to exist in multiple states simultaneously and process information in a parallel manner. The D-Wave's quantum processor operates through this thing called quantum annealing, a process that explores different possibilities and finds the optimal solution to a given problem. Quantum annealing involves manipulating the qubits to represent potential solutions, and then it uses quantum fluctuations to converge towards the most efficient configuration. Now that's complex, but the journey in quantum computing dates back to its founding in 1999. The company introduced its first commercially available quantum computer, the D-Wave 1, in 2011. Since then, D-Wave has continued to refine and enhance its quantum processors, culminating in the development of advanced systems like the D-Wave 2000Q. In terms of computational speed, the D-Wave quantum computer exhibits advantages for specific types of problems, particularly optimization tasks. Its quantum parallelism allows it to explore a multitude of potential solutions at the same time, offering a potential speed-up compared to a classical computer. The assembly of a D-Wave system involves the integration of the quantum processor, cryogenic cooling systems, and control electronics, and the precision required in the assembly process ensures reliability of these operations. These quantum computers have been utilized in various fields, machine learning and scientific research. Notable collaborations include partnerships with companies like Volkswagen, NASA, and Google, exploring the potential of quantum computing in solving real-world challenges. Number 4. The Altaros BAT. The Altaros BAT, or Buoyant Airborne Turbine, is an innovative and high-altitude wind turbine designed to harness strong and consistent winds at altitude that traditional wind turbines can't reach. Developed by Altaros Energies, this airborne turbine represents a unique approach to generating wind energy. It operates as a helium-filled aerostat that carries a horizontal axis wind turbine into the sky. It ascends to higher altitudes where wind speeds are more consistent and stronger compared to ground level. The turbine generates electricity as it spins in response to the wind, and the power is transmitted down a tether to the ground station. The BAT's design combines elements of aerostatic and wind energy. The aerostat is filled with helium and it provides buoyancy, allowing the turbine to ascend to altitudes of up to 2,000 feet. Traditional wind turbines are limited by their height, but the BAT overcomes this limitation,
I think that veterans are trained, myself included, that pain is something that is not expressed.
By their height, but the BAT overcomes this limitation, offering a potential increase in energy production. It's really suitable for off-grid and remote locations, providing a portable and versatile solution for delivering power to areas with limited infrastructure. The BAT is also designed for easy deployment and retraction. It can be transported to different locations and quickly set up to provide power where needed. This flexibility makes it a valuable solution for temporary energy needs or emergency situations. Altaros Energies has conducted successful pilot tests of the BAT, demonstrating its capability in real-world conditions. These tests have provided valuable data on the turbine's performance, highlighting its potential as a practical and efficient airborne wind energy solution. Number 3, the Z Machine. Located within the Sandia National Laboratories in Albuquerque, New Mexico, the Z Machine stands as a pinnacle of scientific achievement, holding the esteemed title of the world's most powerful and efficient laboratory radiation source. This marvel of modern science has the unique capability of replicating conditions not encountered elsewhere on Earth, specifically emulating the dense plasma present within white dwarf stars. Upon activation, the Z Machine channels a staggering 20 million amps of electricity, surpassing the power of a lightning bolt by over 1,000 times, towards a minute target. Within this target resides a diminutive metal container hosting hundreds of tungsten wires finer than a human hair. These wires undergo a transformation into plasma, mirroring the material found in stars, allowing scientists to scrutinize the composition of this star stuff within the confines of our own planet. The Z Machine's origins trace back to the 1970s, when the Department of Energy sought to simulate the fusion reactions of thermonuclear bombs in a controlled laboratory environment. This pursuit led to the establishment of the Z-Pulsed Power Facility, commonly known as the Z Machine, in 1996. The scientific principles underlying its operation involve intricate concepts such as Z-pinch, Lorentz forces, plasma compression, and magnetohydrodynamic instability. The machine notably contributes to weapons research by providing critical data for computer models of nuclear weapons. The data aids in assisting reliability and safety of the U.S. nuclear stockpile. Furthermore, the Z Machine emerges as a beacon of promise in the pursuit of fusion energy, showcasing the potential to generate more energy than is inputted, an essential stride towards sustainable fusion. Beyond its impact on weapons and energy research, the Z Machine delves into the cosmos, offering insight into star formation and the activities at their core. It does challenge existing theories related to ions in the accretion disks of black holes. Despite its profound significance, the Z Machine remains inaccessible to the public, necessitating navigation through substantial bureaucratic processes for entry into the Sandia National Labs. Number 2, 500-meter aperture spherical telescope. So as the name would suggest, the 500-meter aperture spherical telescope, aka FAST, is a colossal radio telescope located in Pingtung County, Guizhou Province in China. Developed to explore deep space and detect signals from celestial bodies, FAST stands as the world's largest single-dish radio telescope. Construction of it began in 2011, and it was officially completed in 2016. The telescope's development aimed to enhance China's capability in radio astronomy, making strides in space exploration and understanding the universe's mysteries. Its primary function is to observe and collect radio signals from outer space. It operates in the frequency range of about 70 megahertz to 3 gigahertz, allowing for the detection of a wide range of signals. The telescope's enormous size enables it to capture those faint signals from distant galaxies, pulsars, and other astronomical phenomena. The dish, with a diameter of over 1,600 feet, reflects incoming radio waves to a focal point, where a receiver system captures and processes those signals. The focus cabin, suspended above the dish, houses the receiver system, allowing scientists to analyze and study the collected data. Its design centers around its immense parabolic dish, comprised of over 4,400 individual panels. Now, the shape of this dish facilitates the precise reflection and collection of those radio signals, and its mobility is limited, but but its innovative design compensates for this limitation. FAST's colossal size makes it an engineering marvel, surpassing the Arecibo Observatory's dish in Puerto Rico, which previously held the world's largest single-dish radio telescope record. The construction of FAST required the relocation of over 9,000 residents to create this radio quiet zone, minimizing human interference. In 2020, FAST made headlines by discovering over 100 pulsars, rapidly rotating neutron stars that emit beams of electromagnetic radiation. The telescope's sensitivity and large collecting area contributed to this remarkable feat in radio astronomy. Number 1. The International Thermonuclear Experimental Reactor. The International Thermonuclear Experimental Reactor is a monumental collaborative project involving 35 countries, aiming to develop a functional and sustainable nuclear fusion reactor. It's located in Provence, France. ITER, as it's called, stands as a beacon of international cooperation in the pursuit of clean energy. The conceptualization of ITER dates back to the 1980s, emerging as a response to the energy crisis and the need for alternative power sources. The ITER agreement, officially signed in 2006, marked the beginning of a shared commitment to advancing fusion energy research. ITER's primary objective is to demonstrate the feasibility of nuclear fusion as a viable and sustainable energy source. Fusion, the process that powers the sun, involves combining light atomic nuclei to release energy. The reactor aims to replicate and control this process on Earth, offering the potential for abundant and clean energy. At the heart of ITER is a massive tokamak, a device that uses magnetic fields to confine and control a hot plasma of hydrogen isotopes. This plasma reaches temperatures of hundreds of millions of degrees Celsius, initiating those fusion reactions. Then the energy released from these reactions is harnessed for electricity generation. The tokamak's design comprises intricate magnetic coils, a vacuum vessel, and a myriad of diagnostics instruments. The complexity of the design arises from the need to create and sustain the conditions akin to the sun's core. ITER has the distinction of being the largest tokamak ever constructed, with a total mass exceeding 23,000 tons. The collaboration in ITER extends beyond scientific endeavors, with nations contributing not only financially but also with expertise and components. The cryostat, a colossal stainless steel vessel housing the tokamak, was manufactured in India and transported to France for assembly. Additionally, ITER's research findings are shared globally, contributing to the collective knowledge in the pursuit of fusion. ITER's journey has seen significant milestones, including the completion of the tokamak assembly in 2020, and this monumental achievement marked a crucial step towards realizing this ambitious goal set by the international collaboration. Thanks for watching, guys. I will see you next time.
Like, subscribe, hit the bell, turn on notifications if you like this video. Share this video. Comment what else you want to see. And yeah, we on the road to 500 subscribers. Always stay turned, gang. Peace. And we out.